Okay. So last class we discussed about now creating our first lab in Cisco packet tracer. Hope you guys remember. Okay, so I'm just gonna do it one more time so that you guys can just look into my configuration. Okay, I hope you guys also did the lab, guys. I told you in the last class itself, if you're joining the classes without doing the lab, then you will not continue this class because you will feel it's boring if you're not practicing it at home. Okay, so I'll tell you what we did in the last class. We started this Cisco packet tracer application. We just added this router. Today I'll tell you why we need this router, why we should not use any other router. I'll tell you. Okay, so next we'll take a couple of switches, right? I'm just taking this switch and this switch. Okay, and then I'm taking devices, like PCs, I mean. Okay, so yes. So now I'm just going to connect them with the cable. Okay, so yes, I'm just going to connect this guy with this guy. Again, this guy with this guy. See, this is something that we discussed in the last class, right? Not anything new. Okay. So I'm just setting up the lab because I didn't save yesterday's lab, so I'm just redoing it again. That's it. So that people who missed last class can also know what we did in the last class. Okay, so we created a small lab like this. Okay, so after that we configured IP addresses to the devices, right? Okay, so how was the IP address configuration? So we had this was the interface 0/0. Yeah, that was 0/0 interface of the router, and this guy was 0/1 interface of the router, right? And we had an IP address of 192.168.1.1. Okay, and this guy is 1.2, and this guy is 1.3. And this guy, we decided to have a new IP address, a different IP address, a different network. So 192.168.2.1, 2.2, and then 2.3. Yeah. Yes. So in this case, the gateway for these two devices is going to be what? What is going to be the gateway for these two devices? Yeah. So just say, I know the chat is disabled, but just guess. You can understand it. Okay. So 1.1 is going to be the gateway for these two devices because that is a router IP address, right? Okay. And what is going to be the gate for these two devices? They're going to have IP address of 2.1, the gateway. So this is the device IP address. This is the gateway IP address. Okay, let me just go and configure this real quickly. So let me just take the PCs first, configure them fastly. Okay, so 192.168.1.2 is the PC IP address. Gateway IP address will be 192.1.1. Sorry, I gave wrongly. Let me type that again. 192.1.1. Okay, now let me just go and take this guy, go to desktop section, IP configuration, 192.168.1.3, 192.168.1.1. Okay, yes. And this PC, it's going to be 2.2, 192.168.2.2. Gateway is going to be 192.168, sorry, 192.168.2.3. Okay, good. Let's go and take the last PC. 192.168.2.3, gateway 192.168.3. Okay, good. So we configured all the 4 PCs. Now let's get into the router. So in the router, the initial thing you'll be asked with a question yes or no. Just give no and get the CLI. So we are getting with the enable mode, EN, and config, and then interface is interface FA is 0/0. IP address 192.168.1.1. 255.255.255. That is a mask, no shit. Okay. Exit interface FA is 0/1. IP address 192.168. 2.1, 255.255.2.0. No shut. Okay, good. So I configured. So fine. Now we just configure all the IP addresses to all the devices. Next, how do we check this? Guys, let me enable the chat for now. Can you guys tell me how do we check the connectivity between the devices, guys? Yeah, please ping in the chat. I told the answer already. Yeah, so ping. Okay, so ping is a command, right? So we can ping and check. Okay, so now, yes, thanks. Let me take this PC, go to the, let me close this IP configuration, go to the command prompt, and I'm just going to ping 192.168.1.3. So I'm just going to test whether 1.3 is connected or not. Okay, 1.3 is in the same network. So yes, of course, I can ping 1.3, no issues. Let me try to ping 192.168.2.2. Okay, so when I try to ping 2.2, We are not getting the reply now. Let's wait. Okay, we got one request timed out, but again, all the other replies are coming. See, this is a normal thing only. I told you in the last class itself. Don't worry about this. Let me just ping one more time just to get all the ping replies. Okay, so if you get one request timed out, that's absolutely fine, please. No issues at all. Okay, yeah. So till this point only we covered in the last class. Right, again, I'm telling you, right, the number of participants compared to last class and this class, we have more participants attending this class. But those who are new to this part, those who didn't attend the last class and joining this class directly, no chance that you guys understand what I'm saying right now. Okay, so that's why I say keep attending the class and don't miss the classes. Okay, yes. So maybe once the recorded session is shared, you guys can check it out. But live classes you'll not be able to understand. Okay. So why is the request signed out happening? I'll tell you that later when we discussed about a concept called ARP. Okay. So yes. So let me disable the chat right now. Okay, fine. So now let's go and create one more network, right? So I'm just trying to create one more network over here, like this. Like, please wait. Let me arrange these devices. I'm just gonna have this guy over here. So listen to me carefully, guys. This is important because we're gonna discuss about a very important concept today, which is a routing table. Okay. Yes. So please listen. Okay. So now here, let me take this switch, and then I'm just gonna add one more switch. Maybe you can take any switch you want. Let me add the switch itself. Right. I just added one more switch. Right. We're just gonna have a third network here. Right. I'm just adding a couple of devices. Yeah. So here I have a couple of devices. Okay. Let me connect them with the cable. So I'm just gonna connect this PC with this switch. Again, this PC with this switch. Okay, which means I'm just trying to bring a third network inside. Okay. So now let me just go and connect this switch to the router, right? So we have a router now. So like how we connected other switches to the router, I'm trying to connect this switch to the router. Okay, I'm clicking on the switch, going to the 0/3 interface and connecting to this router. Okay, and you can see that we have only two ports that is available. That the name of the ports were auxiliary and console. See, I'll tell you one thing. These are the ports that cannot be used to assign IP addresses. The auxiliary and console are different types of ports. The purpose of those ports are different. Right? What type of port we need? Okay, when I connected over here, did you guys notice what was the interface? Fast Ethernet 0/1, right? We need some kind of a fast Ethernet interface. But now, what interface I have when I connect this switch to the router? I don't have it fast Ethernet because why? Because this router has got only two interfaces, right? So it has got only two interfaces, and two network interface card. So this model router has got only two network interface cards. So this is 0/0 and this is 0/1. So only two interfaces, we connected two switches. So we don't have, when I add a third switch, when I try to bring a third switch over there, let's say switch 3, and I try to connect to that particular router, it doesn't have space to connect that particular switch. Okay, because by default, this model, the model that we took, right, 2811 router model, has got only two interfaces. You can connect two switches, but you cannot connect the third switch because it has got only two interfaces. Okay, now what I can do is, and now let me just because again you cannot connect these. If you connect, that's completely waste, right? These are the interfaces. These are not networking interfaces. They are for a different reason. Okay, so now let me just leave my cable by pressing the escape key. Now what I'm going to do is I'm just going to go and add a module into the router, which means I'm just going to go and add a port to the router. Okay, see, listen, this might be new for most of you guys. I'll go to the physical section, right, and I'll just zoom in. So if you go to the packet tracer application on the router, when you go to the physical section, you can see something like this. Okay, let me take a screenshot of that. Okay, so this is a diagram, right? You can see, here, this is nothing but this is the model, right? This is 2811 routers model. This is how they physically look like. And did you see here, when I go to the packet tracer application, physical device view, how the router physically looks like? This is the router looks physically, right? In which this is the front side. This is the front side of the router. and this is the back side. Okay, this is the back side of the router. Okay, so in the front side, what you have Cisco logo and few ports over here. And can you see these are the ports which I ignored. I told the ports which we cannot connect a switch to. These are the ports, right? This is very small, but I can read this. This is AUX auxiliary, and this is mentioned like console. Okay, that is written over there. So these are the two ports which we hesitated to connect, right? We don't want to connect the switch, the third switch to this port. Okay, and if you see, there is a power button, right? If you just click on this power button, the router will go down, right? But don't do that. If you're doing the lab parallelly, don't click on this power button, guys. Please wait. Okay, this is a power button. If you just hit on this power button, the router will be turned off, right? Like now, I switch control. Okay, so here, now here you can see this is the port. This is what, right? If you see, this is very small, but I can say this is FA0/04 phase. And it is written over there, but it is small. FA0/1. So these are the two ports. And what did I do? We connected this guy, we connected to switch one. And the first switch we have, right? The switch one, we connected. And switch one, and this port is connected to switch two. Okay, can you see this is a logical diagram? This is how the diagram looks in a topology. But if you see physically how it is, this interface of the router is connected to switch one, right? Let me put switch one, and this interface of the router is connected to switch two. Okay, yeah. So now here again, I'm connecting. Already the P's are connected, right? These are the PCs. So these are the PCs. These are the PCs that is connected to the switch one, right? That is what I'm just writing over here. So these are the PCs which has got an IP address of 1.2, 1.3, and this guy has got IP address 1.1. Can you relate, guys? What is happening? Okay, can you relate? This is 1.1 interface. Okay, and this is switch to which we connected the other two PCs. Right? We have PC over here. And what is IP address they have? They had IP address 2.2 and then 2.3. And what is IP address of this interface? 2.1. Hope you guys can relate what exactly happened. Okay, now here is where we added a third switch. Okay, switch 3. Okay, this switch 3 is this guy, right? We just added this switch 3. And when I try to connect this switch 3 to the port, it says no port available. And also we cannot connect to this port also, right? This port is also not possible because they are not networking ports. So now only two ports are available in this model 2811. And those two ports are taken by switch 1 and switch 2. Now when I take switch 3, I don't have a port. So now what I can do, right? Can't I connect switch 3? You can connect, but how you can connect is, can you see these free spaces, guys? Can you see this black color? These are free empty slots. These guys are free. No nothing is connected over there. Okay, these are free. And now what I can do is I can go and add an interface into this particular place. Right? It's simply like you can understand when you buy mobiles, right? Nowadays, we have only inbuilt storage, right? You buy a mobile with 128 GB or 256 GB. Internal storage is there. But if you guys remember some 5 to 6 years back and all, if you buy a mobile, the mobile will have some, it will have some 32 GB of storage inbuilt, and they also give additionally, they give you a memory card slot. Do you remember that memory card slot? Okay. So what is the purpose of that memory card slot? To increase the storage, right? They give internally 32 GB, and if you want to increase, you can put a memory card and increase your storage, right? This is what we have been using in mobiles few years back. Now everything become internal storage only. There is no memory card concept nowadays. But back then, 3, 4 years or maybe 6, 7 years back and all, we had a memory card concept. The same thing only. Here, this router comes with two interfaces inbuilt, but if you want, you can add some interfaces in these places and all. That is why they are black. They don't have anything connected over there. Okay, so they are basically called as empty slots. Okay, so now I'm just trying to add an empty slot over there. I'm trying to add an interface over the empty slot. Okay, let me try to do that. Okay, so here if you go, can you see the modules case here? Right, these are the modules. There are a variety of modules that we have. I'm not going to go through each and every one. I'll just go and take this guy. So the name of this module is NM1FE2W, right? NM1FE2W. And you can even just go through the description over here if you want. I'm not going to go through that. I'll just take this NM1FE2W and I'm just going to drag and drop it over here. Can you see? Just like that, I can drop. Now, when I try to drop, the router says that cannot add a module when the power is on. Right? The router is right now running. Right? The running router, in the running router, you cannot go and add a module because why? You can see, can you see there is a power button that is running? Okay, this means the switch is on, right? Which means the router is running right now. You cannot add a module when the power is on. That's what it says. You cannot add an interface or you cannot add a module when the power is on. Okay, again, when I try, see, I'm adding, but it's not saying, it's not accepting it. So I need to power off this router. So one thing is, if I power off this router, if I power off this router, then what happens is all my configurations will go away. What is the configuration that I've done so far? So if I power off this router, if I power off this router, just like that, I'll be losing this IP address after on it. After power off, if I power on, then I'll be losing these configurations, right? Because 1.1, 2.1, they are configured on the devices. If you power off, just like that, you will be losing it after you start the router. After power off, power on, these IP addresses will not be there. So what we have to do is we have to save the configuration first. So first, let's save the configuration. After saving the configuration, let's go and power off the router. Got idea? So first we have to save and then we can click on this power button to power off the router. So how do we save the router? How do we save the configuration? How do we save the IP addresses? I'll go to the CLI back. Right? Now I'm going to go to the enable mode of the router and the command is write to save the configuration. It's very simply write. Write means just save it. Okay. I'm just writing it. So it says the building configuration. Okay, everything is good. It says the configuration has been saved. Now we can confidently we can power off the router. Okay, we just click on this power button. Can you see power off? Can you see that the line was in that light was glowing earlier, right? Now it is not glowing because right now the router is in off state. Okay, now let me drag and drop over here. Can you see this place? I've added this NM1FE2W module. Can you see there is one interface that you see? One more NIC has been added. Okay, already the router has got two NICs or two interface. Now one more NIC has been added. Okay, now let me power on the router again, right? So this is what exactly. See, even in real router also, this is a simulated router base, but even in real router also, you can add modules like this, right? And why specifically I asked you guys to take this 2811 router is, right? 2811 router. Only this 2811 router has got these many empty slots. Can you see? These guys are empty. Still you have empty over here also. See, if you want to add more interfaces, it is possible to add in 2811 router. Whereas the other models and all in packet tracer, the other models that you have, if you click on the router, the other models that you have, these guys they don't support that many interfaces or few routers, they don't even support additional interfaces. Okay, I hope you guys understood why I asked you guys to specifically take 2811. In 2811 only, you can add modules, right? You can add two, you can add four modules also. Okay, so fine. Now let me just go and try to connect this switch to the third module or to the one that I added. Okay, so let me just connect the switch to the router. Okay, and now can you see this? We have the fast Ethernet. Now it's showing up. Right, which one is showing up? This is nothing but the interface that we added. Okay, so let me just select this and connect to that thing. Okay, so I just connected to that particular interface. And what was the, let me disconnect and connect it again, right? What was the number that we have? FA fast Ethernet 1/0, right? Okay, so now let me just take this. Okay. So now this is a diagram that we have. And what was this guy's number, guys? Fast Ethernet 0/0. This guy was fast Ethernet 0/1. And what was the new interface got number? It got 1/0. So don't ask me why it is 1/0, why it is not after 0/1, why it is not 0/2, why it has got 1/0. Don't ask such questions and all, guys. Let's not get into those things and all. Right? Let's simply understand that if the interface name is 1/0, then we will use that number or we'll use that name to configure the IP address to that NIC. That's it. Okay. So these questions are not encouraged. Why it is 0/1, why it is not 0/2 and all. Not really important to know. Whatever number or name you see, just use that number to configure that interface. That's it. Okay. So yes. So we have what we have 1/0. Okay. Already IP addresses are configured to which interfaces. This guy has got 1.1. This guy has got 2.1. Right? And we have IP address like 1.1, sorry, 1.2 over here, 1.3. These guys, they have a gateway of 1.1. And right, these guys, they have 2.2, 2.3. They have a gateway of, let me use different color, red, let me use 2.2, 2.3. They have a gateway of 2.1. And here also, we're going to have a 3.1, of course, right? And 3.1. And this case will be 3.2, 3.3. Okay. And what is supposed to be the gateway for these two PCs, guys? Right. I'm checking the enabling the chat, please. Chat. Just give your answer in the chat. What will be the gateway indicators for these two devices? Yeah. So these two devices, what is going to be the gateway for them? Please answer. Yeah. Very good. Very good. Very good. Nice. Thank you. Okay. So yes. Thank you. Let me stop the chat. So I saw one guy asking a question in the chat. Okay, how this interface become green? Because usually what we do, we just planned this 3.1 IP address. We not configured. We just planned that. So we're gonna configure 3.1 now only. And usually this interface will be in red only. No, it will be in shutdown state only, right? It is in shutdown state only. Then why it is in green? See, this is not a thing that we have to discuss. Like understand it like this. Thanks for noticing it. I don't know how many of you noticed that. Thanks for the question. See, usually what packet tracer, how packet tracer works is any new interface that you add, any new interfaces you add, okay, by default, the new interface goes to no shutdown state. That's it. Okay. So if you have a question of why this guy got green, it's a new interface. So Cisco packet tracer puts him in no shut state automatically. Okay, that's it. Let's just understand that point and we can continue with our class. Okay, so let's go and configure the PCs maybe first. We'll just go and configure these guys. So they're gonna have 3.2 IP address, 192.168 at 3.2, gateway 192.168 3.1. Okay, so here you go, desktop IP configuration 192.3.3, 192.3.3. Okay, good. So now let's go to the router and configure the third interface. Okay, en config interface G0 slash interface FA 0. Sorry, what was that number? 1/0, right? That was the third one, right? 1/0. And IP address 192.168.3.1, 258 or 258 or 258. Okay. See, I told you this interface is already no shut state only, right? But still, if you give no shut, that's okay. There's no issues at all. The interface is already in green only. The interface is already no shut state. But still, as a habit, if you give no shut, that's not going to hurt anything, right? So it's already no shut. But again, you are just giving the same no shut command. No impact on this command, but if you give it, it's not going to be harmful. Okay, so let's give exit and come out of this FA1/0. Okay, so now all we need to do is we have to check whether 1.2 can talk to 3.2 or not. That is what we wanted to verify now. So we already pinged 1.2 to 2.2, it was working. Now let me ping from 1.2 to 3.2 just to check whether it is also reachable or not. Okay, so I'm going to take this PC, right? Already we pinged 2.2, so I'm just going to use up arrow key and change this 2 to 3, and let's ping 3.2 and see what happens. Maybe the first packet expected to be a packet loss. Fine. Okay, let's wait. We'll be not getting the second one also. Okay, there you go. So I lost first two packets, but the next two packets I received. Fine, absolutely fine, no issues, right? Even if I lost two packets, no issues. Let me just try it one more time. And now you can see I can ping all four ping packets are successful to 3.2. Okay, yeah. So we just added a network. So initially, yesterday's class, we had only two networks because we had only two interfaces on the router. Now we had three interfaces on the router. Okay, so we are connecting three networks. Right now, the router is connecting three networks. Okay, simply from what we have learned so far, right, in the last class and today's class, now can you guys define a router base? What is router according to you? Because we all know router is a device, but now can you understand? Can you answer from your understanding? Can you say what router is? Routers connected. Routers used for what? Routers used to connect what? It's used to connect different networks. Different networks. Clear. Now we are understanding the definition from what we learned. We are not learning the definition, or we are not learning definition from any textbook. We are giving definition from what we learned. So this is how it should be. This is how you have to learn something. Hey, don't read the textbook and just don't say, okay, what is a router, router something, so on, so blah blah blah. You should not learn like that. Understand Practically what a router does here, it is connecting different networks. So simply give definition like router is nothing but connecting different networks. Okay, now let's give a definition for a switch. What is a switch? So what switch is doing? Switch connects what? Connects devices in the same network, correct? Switches Switch connects devices in the same network. So this is what we understood from our lab, from our practical lab. Okay, here you have a switch. What is this guy doing? This guy is connecting 1.2, 1.3, and then 1.1. So switch connects devices in the same network. Router connects different network, right? Very easy, right? So next time when you go for some interview, like what is a router or what is a switch, they ask, just go and say, connecting different networks is what the router's duty is, and connecting devices in the same network is what the switch duty is, right? Very simple. We understood what is a router, what is the difference between switch and a router. See, you might have studied about routers and switches in your college base case. Maybe you might even have a college subject in this semester or previous semester. You know what a router is, maybe theoretically, uh, a switch, right? But now only I think you guys are understanding exactly what it is, right? So far, you guys have appeared for some examination in networking. You guys know what is router. You just memorize some stuff and you write it over there. But now only you're realizing it. Okay, this is what the difference. Router is connecting different networks and switch is connecting devices in the same network. Okay, so yes, fine, good. So now I have one more question for you guys, right? I want you guys to answer in the poll. Okay, so let me just create the poll first and answer the question, ask the question. Okay, so I've saved the question. Yeah, so now let me ask the question and then launch the poll, please. Yeah, please listen to the question now. Okay, you can answer it in the poll once I launch it. Okay, so now the question is, see, I'm taking this PC, right, and I'm trying to send a ping request from 1.2 to 2.2, right? Okay, so since we are trying to communicate to a different network, the packet is sent to whom? The packet is sent to the gateway. Okay, so now this guy is going to get the packet. Okay, now once the packet reaches this guy, so it's gonna leave from this PC, it's gonna touch the switch, and then it's gonna leave to this gateway, right? Okay, once the router gets the packet, a router is gonna see the, I mean, router need to forward the packet, right? Router sees the packet and need to forward it. So my question is very simple, guys. When this ping packet goes to this router's this interface, what will be the exit interface of the router? Okay, will it be option A? Right? Will it be option A is just this type, right? Will the exit interface be here alone, or option B, the exit interface will be both? So which means what I'm trying to ask is, when the packet comes to this interface of the router, will the router forward it to both interfaces, or will the router forward it to one interface alone, which is specifically this guy, because here only you have 2.0, you know. So now my question is, will the router forward to both interfaces, like the black color one, both interfaces, or the green color one, no, it will forward only to this interface, it won't even forward to this interface. So will the router broadcast it, or which means forward to all the other interfaces, or it's gonna forward it only to one interface, right? Okay. So you have a question, the same question is coming up in the poll. You can just answer it in the poll. What will be the exit interface for the destination 2.2? I want everyone to participate in the poll, please. Whatever you guess, please answer. That's it. Okay, I'm not expecting a right answer. I'm just expecting a participation here. Okay. Yeah, enough. Let me stop the poll. I think we got enough submissions here. Let me end the poll now. Okay, I'll share the result once again. Okay, so you can see somewhere around 62% have answered option A. So they 62% have opted for this thing. They guessed this going to be only one interface. And for 38%, right? 62, 38, remaining 38%, they opted both interfaces. Okay, now I'll tell you what the answer is. Okay. See, now the right answer is, of course, option A, right? Which means when the packet comes to this interface, the router have to forward only to the middle interface. Why should it forward to that interface? Right? Because anyway, you don't have 2.2 on this side, right? So the router should really intelligent enough to know that the destination is on this interface. So it have to forward only to the middle interface. So option A is correct, right? FA 0/1 is correct, right? Not option B. Okay, I'll tell you one simple example. Okay, let's say you are just walking in the road. Assume like this, right? You're just walking in the road, and some guy he came to you and asking you, hey, how to go to this particular place. Right? Assume that there is a museum near your home, or maybe there is a park or something like that. Okay, that guy comes to you and he's asking, hey, how do I go to this particular museum, or how do I go to this temple or church? Okay, so when that guy is asking you route, okay, that is what you are here. This is you. Okay, sorry, right? You look so funny, but that's okay. This is you, right? And this is me. Okay, so this is me. Right, I'm just coming. Hey, bro, can you say how to go to this temple, let's say, or maybe to this park or whatever? Let me have temple, please. Okay, I'm just asking you, hey, how do I go to this temple? Now you have what options here? If you know how to go to the temple, you just guide me, right? Okay, hey, go straight for 1 kilometer. You'll have a signal, take right, and then again go for 2 kilometers, take left. You just guide me if you know where the temple is, correct? Okay, maybe let's say you don't know where the temple is. You don't know, right? Because even you are new to the place, or maybe you don't know the where the temple is. Now what you will say, right? You will say, sorry, ask someone else, right? I don't know, right? That's what your response should be. I don't know. Okay, so you either you can route me or either you can route me. Right now, when you say the direction to me, then you are routing me or you are routing me. When you say the direction, you are routing me. If you don't know the direction, you are just saying that I don't know. Okay. See, can we have one more answer, guys? Okay, assume that I came to you and asking, hey, bro, can you tell me where this temple is? And you say, since you don't know where the temple is, you are just saying, like, hey, bro, go in all directions. Yeah, go in all directions. Just go to all streets, right? Go in all directions. Someday, you will reach the temple. Someday you will reach the temple. Is it right way to answer someone who's asking for route to some particular destination? Right? Okay. Can you say to me that hey, go in all directions, right? Just go everywhere, go in all directions. Someday you will reach the temple. Right? Why you should say that? I even know that. Right? I know that if I go in all directions, someday I'll reach the temple. And why should I go and ask you that? Okay, got the clarity, right? So people who opted for option B, right? So people they're saying like FA 0/0/1 and then FA 1/0. Basically, you're saying that hey, router will forward in all the interfaces. Right? If the router is forwarding in all the interfaces, then why do we need to have this intelligent device over there? This intelligent device should do what? This intelligent device should find out where the route is and he need to forward it only to the right interface. Makes sense, correct? Yeah. So now I'm just done with my template example. Okay, let me erase it. I hope you guys understood, right? My example, my analogy here. Okay. Yes, fine. So what is correct? So option A is correct, right? Which is this is the middle interface. That middle interface is one that's gonna leave. Okay, so that's correct. That's the correct answer. So the packet will come to the router and ask for the router. Hey router, where is 2.2? The packet is asking. Imagine like this. When you want to learn networking, you also need little bit of imagination thinking, guys, right? You need to have some imagination brain. Okay, now assume that the packet is slowly coming to this router and asking, hey router, can you say where is 2.2? The router should forward the packet out of the middle interface, right? Because the router should know that 2.2 is behind over there. Okay, so yes, so which is right answer? Option A, which is the middle interface alone, FA 0/1 alone. Okay, there is no point in sending to the other interface. It makes sense. Okay, now my question is, the question that I have right now is, okay, in that case, how will the router know, right? In that case, how will the router know? Okay, so we agree that the router should be intelligent and he should not forward on the other interface and all, or he should not forward to both interfaces, we understand. But how will the router know that, okay, let me just undo all these things. But how will the router know that this is the exit interface for 2.2? Or how, my question is very simple, guys. How will the router know that 2.2 is connected behind this middle interface? How will the router know that? How will the router know that here is where you have 2.2? Or how will the router know that you need to leave this interface to reach 2.2? Because the router should know it some way, right? In which way he knows it? That's what my question is. Okay. Yeah. So I'll itself tell you, right? You might have variety of answers with you guys. Fine. So let me simply tell you what the answer is. Okay. See, the router will maintain a table called routing table. Router will maintain a table called routing table. So with the help of that routing table only, a router will route the packet. Again, understand this phase coming to the router asking for the route. Now router will check this routing table, get the information from the routing table, and based on the information that you got from the routing table, you'll forward the packet to the middle interface, right? Okay, now all we need to do is we need to explore how the routing table is going to look like, or what in all the routing table has got. Okay, so let's go and understand routing table in few minutes. Right? Before that, I just want you guys to understand this. Okay, before we see routing table, let's just go to a different slide and understand some basic subspace. Okay, so here I have 192.168.192.168.1.x. Okay, let us call it as x. Right now, what is going to be the range for this as x? X can vary from where to where? So it can vary from 0 to 255. We all know that, right? So 0 to 255. So in that case, what is the first IP address in this network? What is the first IP address in this network? 192.168.1.0. Am I right? Yeah, that is the first IP, that is the first address. The X range from 0 to 255. So 1.0 is the first IP address. So what is the last IP address? 192.168.1.255. Yeah. Okay, so 1.0 is the network, 1.0 is the starting address, and the last address is 1.255. Okay, so now 1.1 is the second IP. Okay, and 1.254 is the second last IP address. Okay, so now we have this range. This is, and how many IPs we have in this network case? We have totally 256 IPs, correct? Okay, starting from 0 to 255. 256 IPs are there. Okay, my question is very simple now to you guys. What happened to 1.0? If you see my diagram, right, I started with what? I started with 1.1 only. No, what happened to 1.0? Why didn't I use 1.0? Have you guys thought about this earlier? If yes, then good, right? If not, at least now think about it. Why didn't I use 1.0? Why did I start with the second IP? 1.1 is a second IP. That's the second IP. Why did I start with second IP 1.1? Why didn't I use it like this? Why didn't I make it like this? 1.0 over here, 1.1 to this PC. Okay, 1.2 to this PC. Why didn't I start with 1.0? Why did I start with 1.1? Because the reason is you cannot use 1.0 because 1.0 comes under a reserved category IP address. So 1.0 in the sense I mean by the first IP address. The first IP of any network, understand this is very important in networking. First IP address of any network is reserved. Okay, and we're gonna call that IP address with the name called network address. Network address. Clear? Okay, so the same way, this IP address, this is the last IP address. So last IP address of any network, last IP address of any network, that is also reserved, and we're gonna call that as broadcast IP. Okay, broadcast IP, or you can call this broadcast address. Okay, so clear. The first and last IP address or reserved case. Even if you try to assign 1.0, if you go to the router and if you assign 1.0 IP, he will not take it. He will reject it. He'll say that this IP address is wrong. He'll say something like that, invalid IP. So you cannot take the first IP to the router or even to the PCs you cannot give. Right? I'll just show you, see, listen here. I'll go to this PC and let me give 1.0, just see what the result that the PC is giving is. I'm just going to change from 1.0 to 1.2 to 1.0. I'm just giving 1.0. Let me take my hand out and what it says, invalid IP address. It says you cannot configure it. Let me configure it back to 1.2 itself. So now you guys are understanding that the first IP is reserved, the last IP is reserved. So in that case, we can have only how many IP addresses? So 256 minus first and last minus 2. So you have only 254 IPs usable, right? So 250 IPs usable, we're going to call this as host IPs. So basically usable IP addresses. Okay, 254 IPs are usable. First and last cannot be used. First and last has been reserved. Okay. Now coming to the next question, why it has been reserved? Because if someone reserves something, there should be some reason for it, right? No one will reserve. If you reserve something, you have a reason for it. The same way in networking, why the first IP address is reserved, right? If first IP address is reserved, then there should be some reason for it, right? Okay, why it has been reserved is, right? Or I'll tell you what is the purpose of network address. Both are same only. Network address is basically the representation address. Network address is basically a representation address. Okay. So now, if I wanted to express, right, I just wanted to call all these IP addresses, right? If I just want to refer them, if I wanted to refer 1.1, 1.2, 1.3, like no, assume 1.4, 1.3, all these pieces are here. If I wanted to refer them with single IP address, right? Again, understand? If I want to refer them with single IP, then I can use a representation address or representation IP, which is called as network address. Okay, maybe if you're not understanding it now clearly, don't worry, guys, you will understand it slowly, right? Because this portion might be confusing now, but of course, in maybe today's class itself or maybe in tomorrow's class, definitely you'll be able to understand what I mean by. Okay, so network address is a representation address. What it is, it represents all the IP addresses below, right? If I say 1.0 is what I'm using. If I say, hey, my network is 192.168.1.0, or if I say my network or my PCs are in the network 192.168.1.0, then what I mean by, I mean, these are the IP addresses that I use, right? All the IP addresses below are represented with the first IP address or represented by the first IP addresses. Very good. Now let's go with the last IP address. So, understood network address, the first address, reserved network address, the name of that is, and that is used to represent all the IP addresses below. Okay, so we'll just go and then understand what is broadcast address. If you're not still clear, don't worry, you will understand it in a few minutes. Please wait. Okay, now this guy is the last IP address. This is also reserved, and we're going to call it as a broadcast address. So the meaning of that is, in sometimes in networks, in a network environment, we may need to broadcast, right? One common message for all the devices in the network, all devices in that network. So when you want to send one common message to all the devices in the network, then you can use this broadcast IP address, right? Simply saying, okay, I'll just take this PC, and when I try to ping, let me ping 192.168.1.255. If I try to ping 1.255, what I'm doing, I'm pinging which IP address? I'm pinging the broadcast IP, right? Which is, I'm just sending a broadcast ping, right? Understood? Now I'm sending a broadcast ping. If I ping the last IP address, I'm sending a ping message to all the devices in my network. Okay, so when I ping 1.255, where am I getting reply from? I'm getting reply from 1.1, and I'm getting reply from 1.3. Can you see? Because in this diagram, what devices we have? I'm sending a ping request from here base to the destination IP of 1.255. Who and all replying to me? I'm sending a broadcast hi. Okay, so just take example like this Zoom meeting. If I say hi and if I call one guy's name, let's say that guy is Arun or something. If I say hi Arun, Arun will reply. Okay, that is like unicast. If I say hi everyone, what I'm doing? I'm doing broadcast, right? So what everyone will do? Everyone will say hi sir, hi sir, hi sir. Okay, that is what this guy is doing. right? When I try to ping 1.3, I'm pinging Arun directly, which means I'm just pinging him directly. He'll alone respond to me. When I say hi everyone, what happens? This guy is also responding, and this guy is also responding. Can you see? And if I have more PCs in my network, all these guys will respond. Okay, so that is the power of broadcast. If you want to send one common message to everyone, you are simply saying like hi everyone. Okay, so everyone starts responding to your ping, right? When you try to send a ping to the broadcast IP, right? On one condition, the broadcast works only on the same network, right? Broadcast on same network. So what I'm trying to say is, okay, from here we can ping 1.255. From here you can ping 2.255. From here you can ping 3.255. Got the point? So you can ping only your broadcast IP. You cannot ping other networks broadcast IP. If I try to ping 2.255, right? I'm trying to ping this guy is a this network's broadcast IP. You will not get the desired result, or you will not get the expected results. Okay, so broadcast is only for what? Broadcast is only for the same network, right? You can just ping only your network's broadcast IP. That way only it works. Okay, good. Okay, one more thing. I just want to show you before seeing the routing table. I hope you guys are following the classes, no? Yeah. So yes. So one more thing before seeing the routing table, we just understood there is something called network address. There is something called broadcast address. So now let's understand this calculus. Now we can understand the other format of denoting the mask. So how you generally denote the mask is how the mask is denoted. You can, I mean, if you use mask like this, 255.255.255.0. This is a mask that we use now. When you configure to the PCs and all. Okay, now this mask can also be denoted with slash notation, right? Subnet, this is a subnet mask decimal format, right? You can also denote the mask in slash notation, right? You can also denote in slash notation. Okay, this is slash notation. Okay, so now 255.255.255.0 can be called as slash 24, or can even be denoted like slash 24. Now, what is the relationship they have? Okay, how do I say this 255.255.255.0 as slash 24? Because there should be some kind of a hidden relationship, right? How this is compared with this, or how this is can be mentioned like this. Okay, I'll tell you. Most of you might have already guessed it, but still I'll tell for others. Okay, if I try to convert this 255 into binary, okay, so this is where we are just coming into binary to decimal base. We'll talk about binary to decimal later one class, but not in depth and all, because we don't have time. This is a boot camp, just 30 hours course, so we don't have enough time to discuss everything in depth. But anyway, I'll just touch what decimal to binary later. Okay, now when I try to convert this decimal, right, to a binary value, we're gonna have 8 ones. Okay, if I have all 8 or 1, then it's 255. Then how many ones we have here? The same thing, 8 ones. How many ones I have here? 8 ones. And what is this? If I convert the 0 to binary, then I get 8 zeros. Correct? Okay, now say this is the binary format of my subnet mask. And how many ones I have? I have 24 ones, right? 8 plus 8 plus 8. Right? And we don't have any ones over here, so 0 ones here. So 8 plus 8 plus 8 plus 0, so which gives me 24. Which means if I say slash 24, that is nothing but the number of ones that I have in my subnet mask. Right? When I convert my subnet mask into binary, the number of ones that I have, that is what slash notation is. Okay. So now I'll enable the chat for you guys, and I'm just gonna ask you a question. I want you guys to answer in the chat. Okay, let me enable chat now. Okay, so the question is, what is the slash notation for 255.255.0.0? Please answer this. What is this? Yes, very good. This is slash 16, right? Yeah, yeah. So many guys are answering really nice. Okay, slash 16. Okay, so next question, it's easy. You guys can easily answer it, I know. Yes, so what is the slash notation for the subnet mask 255.0.0.0? What is this? Slash, yes, 8. Okay, so 255.255.255.000/8. Okay. See, I can see you guys are asking some questions, but understand how the classes are going for me. For you guys are just seeing my chat alone. In your chat box, you see only your answer, but in my chat box, I'm seeing everyone's answer. Right? So just like it's like spamming kind of a thing, right? I couldn't even have time to read your questions, right? Just like that going to the top because many guys are answering at the same time. Okay, yes, really nice. Slash 8 is what this submit mark is. Okay, so now we understood a couple of things. The network and broadcast address, what they are, and the slash location. Okay, yes. Now let's go to the router and see the routing table. Okay, so now we are ready to see the routing table of the router. Okay. Let me just undo this and we will see the routing table of the router. Okay, ready? Okay, so let me stop the chat. Okay, so in this case, we're gonna have a command to check the routing table. The command is very simple, guys. We have to use a command called show IP route. Okay, that's the command show IP route. So let's go and see the show IP route command. Okay, so here I'm into the user mode of the router. I'll get to the enable mode, and in the enable mode, I'll give the command show IP route. Okay, so when I give show IP route, we are seeing the routing table. Very nice. Let me just explain about this routing table now. Okay, so listen here. So this is the command that I used, show IP route. So after giving this show IP route command, I can see, just ignore these guys and all. These guys are just ports, ignore them. We wanted to look into these three lines. So this is what the routing table exactly says. Okay. Okay. So this C means the network is directly connected. Okay. So maybe if it doesn't make sense now, please wait. It will make sense. This C is a code. The C says what? The C says the network is connected. Okay, that is what the C is. Maybe you can just ignore the C right now and let me read this. Okay, so what is the first line in my routing table is 192.168.1.0. What is 1.0? What is 1.0? The network address of that network, right? 1.0 is the network address. Okay, so 1.0. What is slash 24? Yeah, again, we just discussed it. What is slash 24? Subnet mask. Okay, so subnet mask 255.255.255.0, right? So now the router says that 1.0, let me undo this, 1.0/24 network. This is a network. That network is directly connected and connected to which interface? It says 0/0. Okay. So can we go and check our diagram, guys? Is it really true? Okay. So yes, what is this network? If I just put a circle, and how do you refer them? What is the network address for them? What is the representation address for them? 1.0/24, correct? Yeah, that is what the router says. Right? This is what exactly, because all these blue color IP addresses, they belong to which network? They belong to 1.0/24 network. Okay. So here 1.0/24 is directly connected to this interface, right? That's correct. That is what the router has got, right? 1.0/24 is connected to the first interface, 0/0 interface of the router. Did you notice this? 0/0. Okay, good. Next is next line. We'll read out the next line. The next line is 192.168.2.0/24. Okay, that is directly connected to which interface? 0/1. Okay, so can we circle these guys now? Oh, sorry, I just did something else. Okay, yeah, now we'll try to understand this. What is the network address of this guy? Hey, 2.1, 2.2, 2.3. What is the network address for them? 2.0/24, correct? Okay, yeah. So that is connected to which interface? 0/1. Wait, again, the router correctly says it. The router says 2.0/24 is directly connected to 0/1 interface. And that is how our diagram is also. The diagram also says the same thing. The routing table is also saying the same thing. Okay. Now, next thing is this guy. Of course, this we can easily understand now. Okay, so let me put 3.1 over here. Okay, yeah. So now what is the network address for this? 3.0/24, right? And then the router says that 3.0/24, that network is directly connected to which interface? Which interface? 1/0 interface. Okay, so finally we got three entries in our routing table, which is 1.0 for this interface, 2.0 connected to this interface, and 3.0 connected to this interface, right? Now the routing table is ready. We saw the routing table with the command show IP route. Okay. Okay. Now coming back to my initial question. Okay. There is a question that I asked, right? How will the router know that? How will the router know 2.2 is behind this interface? That was a question. Let me come back to that question. And now let's try to understand that answer. Okay. Now this packet is going to the, okay, let me erase this and write the routing table over here. Routing table. Okay. So 1.2 to 2.2, that is a source and destination, right? Source is 1.2, destination is 2.2. Now this packet goes to this router and asking that, now just believe like, no, the packet goes to the router and asking, hey router, can you say where is 2.2? The packet is going to the router and asking, hey router, can you say where is 2.2? The router says, yes, sure packet, let me check my routing table. Okay, now it went to check the routing table. In that routing table, what we have, what is the destination IP case? The destination IP is 2.2, correct? The packet is asking where to go to 2.2. Right? Now 2.2 matches under which network? It matches under 2.0 network, correct? Because we know that 2.2 belongs to which network? 2.2 belongs to 2.0 network. So the router checks his routing table and says that you want to go to 2.2, right? And 2.2 is matching on which line? It is matching on this second line. 192.168.2.0/24, right? Your destination is matching under this network. So now that network is directly connected with that network is directly connected to 0/1 interface. So now what the router is after getting the information from the routing table says that, hey, the exit interface is what? Interface is 0/1. After getting this answer from the routing table, now the packet is forwarded only to the middle interface, not to both interfaces. Okay, got the point? I gave you the poll, right? And in that poll, I told you what the answer is. Now I'm justifying that answer. Okay, so now it goes only to the middle interface because routing table says that 0/1 is the exit interface because that is where 2.0 is connected to. Clear? Yeah, absolutely makes sense. Now the ping packet is gonna leave this guy, and there is a small operation that will happen on the switch case, which we'll cover later. And then now it's gonna go to this uh, PC. Okay, yeah. So now this PC got the ping request. Now he need to make a ping reply, right? So he's gonna make a ping reply. Okay, so he's replying. What is the source IP in the ping reply case? Source IP 2.2. What is the destination IP in the ping reply? 1.2. Because why? Because we are replying to him, no? Yeah. So 2.2 to 1.2. Okay. So here, so now what happens is this ping reply, right? Again, I know there are so many scribbles here. I just try to understand. Let me just say it this way. Okay, the ping reply packet goes to the middle interface of the router. Okay. So now this reply packet says to the router, hey router, can you say how to go to 1.2? Now the reply packet is asking again, going to the gateway of the network and going to the router, which is, and asking, hey router, can you say where is 1.2? How do I reach 1.2? Now again, the router says, okay, packet, please let me check my routing table. It goes to the routing table. I'm checking it now. So what is the destination now, please? 1.2. So 1.2 is matching under which line now? 1.2 matches under the first line. Now 1.2 is matching under this network. So this guy is the one who has got 1.2 with them. Right now, 1.0/24 is directly connected to which interface? 0/0. Now the routing table says, okay, so the routing table says that, okay, so the exit interface now is 0/0. Okay, because that is what the routing table information has got. Now this ping reply is now forwarded to the middle, sorry, it's forwarded to the first interface of the router, and now there you just go and you reach here. So this is how your ping reply comes. This is the first ping request and ping reply. And second ping request, the same story. Right, again, you will send the second ping request to the gateway. and this guy will forward to this guy, and then reply again, come back. So same story, guys. If I explain first ping request and reply, the same thing is going to happen for all the subsequent ping request and ping replies. Got the idea? Okay, so the routing table is very, very important for the router. Okay, yes. So without routing table, it is just a stupid device. With routing table is a intelligent device, right? Like a brain of a router. Okay. So yes. So now I have one more question with you, please. Let me please an answer this question. Okay. So let me enable the chat for that, so that you guys can answer in the chat. And my question is, wait, let me ask the question and then enable the chat. Okay, the question is, what is the source of this routing table? Source of this routing table. I can say routing table or I can say routing entries. What is the source of this routing entry? Which means, how did the router came to know that 1.0 is connected to 0/0 interface? My question is, okay, the routing table is there, routing table is fine, but how the router knows it? Because see, here we see the diagram, guys. We see the diagram, we know 1.1, 1.2, 1.3, we know this is 1.0. But how the router knows this? We have a diagram, we designed it. So as a human, I know it. But how the router came to know that 1.0/24 is connected to the first interface of the router? How did he know that? But anyway, what he has in his routing table is correct information. But my question is, how did he know that? Like, did I go and say this router? Did I go to this router and say, hey router, 1.0 this side, 2.0 this side, 3.0 this side? Did I go and say the router where is 1.0, where is 2.0, where is 3.0? I didn't say. I didn't say the router where is 1.0. I didn't say the router where is 2.0. If I didn't say, then how did he automatically understood this? Right? That is what my question is. What is the source of this routing entry? How did this entry created in the routing table? Right? I never told my router these networks are connected to this, and this interfaces respectively. Without me saying it, how the router got to know that? Okay. So let me see who's answering this question. Right? Yeah. So I'm just going to enable the chat right now. Yeah, there you go. Answer. Right. What is the source of this routing table? Okay. Okay. Most of you guys are answering it correctly. Yes. Yes, guys. Got it. Got it. Thank you. So let me just stop the chat again. Okay. Let me stop the chat. Okay. Thanks for answering. So now, I think most of you, I think almost 60-70% of the chats, you guys gave the answer correctly. The source of these entries are the IP address of these interfaces, right? I never told 1.0 is connected to this interface. I didn't say that. I didn't say 1.0 connected to this interface. But what did I say? I say that 0/0's interface IP address is what? 1.1. I gave this, no, I took this interface and I gave him an IP address of 1.1. So since I gave him an IP address of 1.1, what router understood? So let's go back to the diagram. So I gave him 1.1, right? I gave this interface an IP address of 1.1. So the router understood that if you are assigning 1.1 to me, if you're assigning 1.1 to this interface, then mostly you're going to have 1.2, 1.3, 1.4 only behind this interface. You got the idea? So the router is understanding like this. Okay, if you're assigning 1.1 IP address to this interface, or if you're assigning 1.1 to this interface, then you're gonna possibly use 1.2, 1.3, 1.4 only. Which means even these guys, they belong to which network? They belong to 1.0 network only. Okay. So based on the interface IP address, the router understands the network that is connected. When you give 1.1, it becomes 1.0. Okay. So the moment when I was configuring this router, I gave en conf and all. No. After that, what did I do? First time I went to this interface 0/0, and I gave this command, right? IP address 1.1, and then the mask 255 255.255.0. The moment I gave this IP address, the first entry got created in the routing table. You got the point? So by assigning IP address to this interface, we get the routing table. Okay, so the moment I gave 1.1, I got the first line in my routing table. When I configured 2.1 to the second interface, I got the second entry in the routing table. And when I give 3.1 in the routing table, I got third third entry in my routing table. Got the point? So the source of these networks are the IP addresses that we configured for those interfaces. And this is what most of you guys answered. 70% of the answers I just went through. They told default gateway IP, interface IP, that is what exactly they were trying to no, the students were trying to say. That is exactly correct. Okay. So yes, now let's understand this. Okay. So now my question is, if I change, okay, I'm gonna again enable the chat, but I want you guys to answer now. If I go and make this, if I go and modify this IP address, it is 3.1 earlier. Now I'm going to modify it as 4.1. Okay. So in that case, what router will guess this network is? You're going to guess it as 4.0, correct? 4.0. Is it correct? So when I configure 4.1, what will be the network that is directly connected to? 4.0. Yeah. So now let us go and test that also. En conf3 and then interface FA 1/0, right? That is the interface I was talking about, 1/0. This guy has got 3.1, but now I'm going to go and configure in 192.168, 4.1, 255.255.255.0. Okay, no shut is not required all the time. One time you give no shut, that is sufficient. So I gave this. Okay. So now, what is the command to see the routing table, guys? What is the command? Yeah, that is show IP route, correct? Okay, show IP route. Let me try it here. Why it is not working? So when I scroll about this, let me scroll and show you. The same command I gave show IP route command only, but I was using that in the which mode? In the enable mode, right? So in the enable mode, I was trying it. Now which mode I'm trying it? I'm trying in the configuration mode, but the command is same show IP route. Why it is not working? Because why it is not working is this show IP route command. Show IP route command is designed for which mode? It is designed for enable mode. Okay, or it is designed for user and enable. So this show IP route commands are designed for user and enable mode. Now, which mode I'm trying to execute in? I'm trying to execute in the configuration mode. Configuration mode. Okay, so but what we have learned so far is something that works on enable mode should also work on configuration mode. That is what we understood. No, configuration mode is what? This is a highest privilege level. Okay, so if something is working on enable mode, then it should also work on configuration mode. Then why it is not working? It will work. But even though this command is designed for user and enable. Still, if you want to use that in the configuration mode, right, you guys can use it with a keyword do. You have to put it like do, and then you have to give show IP route. You got the idea, guys? Okay. So if you are if you are using the command in user and enable, you can use show IP route. No issues, it will work. If you are using the command in the configuration mode, just add a word called do and say, I want to execute this enable mode command in which mode? In the configuration mode. So I want to execute this command. So I give do show IP route. So I'm just going to give do show IP route. Listen here. Do show IP route. Okay. Yeah. So let me give enter now. Yeah. So we got the same routing table. Okay. So I just gave do show IP route. And what I have here is see 4.0. Okay. 4.0. Because why? Because now only what I configured. I configured this guy as 4.1. So what happened? It become 4.0. Okay. So now, now this is 4.1. So the routing table has got 4.0. Now the gateway is in 4.0 network, correct? And the PCs are on which network? The PCs are on which network? The PCs are in 3.0 network, correct? The PCs, they have 3.2, 3.3. So they are in 3.0 network. The router, the gateway has got 4.1, which means they are in 4.0 network. Now, say, can we have this kind of a design? Right? Is this design right or wrong? Right? I want you guys to answer in the chat. Just say whether this kind of design is can be used or not. Yeah, so now you have the option to answer in the chat. Can we have such designs? Yes, very good, very good, very good, very good. I I saw more than 100 plus commands there, but I think only two guys have told yes, you can have. All the others, they told no, it's not possible. Right? Yes, the answer is it's wrong. You cannot have a design like this. Right? Okay, let me just stop the chat. Okay. Yes, you cannot have a design like this thing. You cannot have, this is a wrong design. You should not have a design like this. If the gateway is in 4.0 and the PC is in 3.0, then it is a wrong design. So what is a dish design? What is the correct design? The PC and gateway should be in the same network, right? The PC and the gateway should be in the same network, right? Maybe if you want, you can just go and change these days to 4.1, 4.2, 4.3, and you can make the gateway as 4.1, or you can go and change this guy back to what? Change this guy back to 3 point. Okay, please wait. Okay, so we'll just go and make this guy, we'll change this guy back to what? We'll change this guy back to 3.1 itself. So in that case, we get what? We get 3.0 back into the routing table. 3.0 slash 1 back into the routing table. So can we change that and again check? I'm just going to use up arrow key. Just already I configured 4.1. Now I'm going to make it as 3.1. Okay. Now let's go and give up arrow again. Do show IP route command. And can you see? You got 3.0 slash 24, right? So the right design is what? The right design is the gateway and the PC should be on the same network. They cannot be in a different network, right? That is what we understood now. Okay. So now, one question, one last question before I finish this session. I'm almost gonna finish this, but one question with you guys. Okay. What happens if I try to ping, right? From this PC, I'm going to ping the 192.168.10.2. Okay. So we don't have the 10.2 PC in the network. You guys know now what we have. We have only three networks, 1.0, 2.0, and then 3.0. But I'm going to this PC, I'm taking this PC and sending a ping request to 10.2. Okay. So now let's see what is the result. Okay, let's take this PC, ping 192.168.10.2. Okay. Yeah. So let me ping and show you the result. Okay. So now let us understand what is the reply that we got. We got the reply as destination host unreachable. We are not getting request time the place. Instead, we are getting destination host unreachable. I'll try to explain now. I know this is very you know, I just use the slide maximum. I will just go and take a new screenshot and explain something it. Okay, so what we have this guy 0/0. This is 1/0. Sorry, 0/1, and then this guy is 1/0. Okay. Yes. Now you have what you have 1.0/24. That is a routing entry connected to which interface case 0/0. We have 2.0/24. That is connected to which interface 0/1. And we have 3.0/24 that is connected to 1/0. So these are the three routing entries that we have got, correct? Okay, so this guy is 1.1 and this guy is 1.2, 1.3. They have a gateway of 1.1. Okay, and this guy is going to be 2.1, 2.2, 2.3. They're going to have a gateway of 2.1, and then this guy 3.1, 3.2, 3.3. They have a gateway of 3.1. Okay, so now when I try to make a ping request, from 1.2, I'm trying to ping a request. I'm trying to ping one initial request to 10.2, right? That is what my question is. So I was using this command ping 10.2 on this PC. So in that case, When I try to ping 10 point, what happens is the packet goes to the router and asking, hey router, can you say how to go to 10.2? The packet is asking the router, hey router, tell me how to go to 10.2. Now the router says, okay, please wait packet, let me check my routing table. And do we have match on this line for 10.2 base? No, because it has got only 1.0. And do we have match for 10.2 here? No. Do we have match for 10.2 here? No. So after checking all the entries in the routing table, the router found that it doesn't know where is 10.0 because 10.2 comes under which network? It comes under 10.0/24 network, right? The router is checking the routing table and seeing it. I checked my routing table, right? I couldn't find where 10.2 is. So I'm just gonna say you that the destination host, the destination device that you're trying to reach is unreachable. Okay, unreachable. Who's saying that? Who is saying that it's unreachable? You see the reply. The reply came from which device? Right? It came from the gateway. The 1.1 PC, sorry, 1.1 router, the 1.1 gateway. When you try to ask him how to go to 10.2, he says what? Hey, sorry, I don't have a routing entry for it. 1.1 is replying to the PC saying that the destination is unreachable, right? So it's responding, right? This guy says, right? This packet says, I want to go to 10.2. So the PC says, hey, sorry, PC, you wanted to go to 10.2, but I don't know where is that. I don't have a routing information for that. So I'm just giving you destination host unreachable. That is the reply I'm getting it. I'm getting it from where? I'm getting it from my gateway. Does it make sense? Absolutely, it makes sense. Okay. So yes, so with this, I'm just going to finish this session. Just one poll I have with you guys. I just to know the quality of the training. If there is anything that I need to improve, I'll check on that. Okay, so yes, so let me just give a rating. Yes, that's it. Okay, so yes, rate this session. That's the question. Okay, so we'll have it like a 10, 9, 8, and the last one is less than 8. Okay, that's the rating that you guys wanted to give, right? The 10 is the highest and less than 8 is the lowest. Okay, just let me ask this question now. Okay, please answer this poll so that I know like how you guys are understanding what you guys are thinking about the sessions. Okay, please answer it. Okay, thank you. Okay, so yes, I can see somewhere around 2% have answered less than 8. Maybe I don't know, they wanted to give me 7 or 6 or maybe 1 also. But one thing is, for people who, that 2% of people who answered less than 8, maybe if you are not understanding this session, that is because you have missed the previous sessions. If you are continuously attending this class, then there is no way that you miss this. Okay. So yes, so if you are not understanding, if you're not understanding it, that is because of the previous class you missed, right? And that might the reason I think it is reflected in the less than 8 category where you have 2%. Okay, so I think the majority is I can say 89% is we have for between 10 and 9. So 10 is 47 and then 9 is 42% and then 8 is 8%. Okay, so yes. Okay, guys, let me end the meeting. See you guys tomorrow in a different session. Thank you. Bye.